Let's go ahead and wrap up our lesson on inequalities by taking a look at some problem solving and word problems. When we see phrases such as at least, most, between, no more, minimum, maximum, any phrase that is similar, we're usually indicating an inequality rather than an equation. But we'll use the same process for solving a linear equation. We'll first understand what's the question asking for, what's being modeled. We'll choose our variable. We'll translate our statement into a linear inequality. We'll solve and we'll interpret our answer. So let's take a look at two examples. A part-time salesperson earns $600 per month plus a commission of 20% of sales. Find the minimum amount needed to receive a total income of at least $1,500 per month. Okay, so we're trying to solve for the amount of sales needed and specifically a minimum amount. So we know since we're solving for the amount of sales, that is our variable, that's our unknown. You don't have to use X, you could use S for sales or anything else, A for amount, but our unknown is representing the amount of sales. So let's think about the model. When someone earns a salary and commission, the amount of money earned on both of those, in this case, needs to be at least a total desired amount, total income. So salary and commission has to be at least the total income. And so we can go through the problem and look and we say, okay, well, this salesperson earns $600 per month plus a commission of sales. So whether or not they sell anything, they're earning $600. And plus their commission will be 20% of their sales. That's our variable. At least represents the inequality greater than or equal to. At least. That needs to be more money. It needs to be that amount of money or more. At least greater than or equal to. The desired income is $1,500. So now that we have our equation, and we know that 600 plus 0.20x needs to be greater than or equal to $1,500, we can go ahead and solve for our variable. Subtract 600 on both sides. Divide both sides by 0.2. And we get an x value must be greater than or equal to $4,500. And then we need to interpret this answer. She needs to sell a minimum of $4,500 of merchandise. Let's go ahead and look at another inequality. In the United States, the percent of adults who are currently smoking cigarettes is declining. The percent P of U.S. adults, there's our variable right there, variable, the percent P of U.S. adults who are currently cigarette smokers each year from 2008 to 2018 can be approximated by the formula given, where T is the number of years after 2008. Assuming this trend continues, use the formula to predict the years when the percent of U.S. adults who are current cigarette smokers is less than 9%. And so they're giving us a value for percent. And we want our value for everything else to be less than that. So starting with our original formula, we're going to rewrite it as an inequality. So we're looking for when P is 9 and everything else needs to be less than 9. The actual percent needs to be less than 9. So we can rewrite the inequality. The percent of smokers needs to be less than the 9. So we can go ahead and solve. And we end up getting negative 12 is greater than negative 0.72t. And we can divide by both sides by our coefficient. Now, because we divided by a negative value, we need to remember to flip our inequality. So 16.6 repeated. Now instead of being greater than is now less than the value of t. T is greater than 16.6 repeated. So we can round that up just for the sake of it being a real life problem. 16.7 t, or 16.7 has to be less than t. So we're looking for 16.7 years after 2008. Well, what year are we in? 16.7 years after 2008. We are in the year 2024, which is this year, somewhere in the middle of the year 2024 or later. So based on this model, at this point in time, hopefully the number of adults who are cigarette smokers is less than 9%.